The displacement of a body along x-axis depends on time as root x is equal to t plus 1, then the velocity of the body is c. All these questions are based on JEE exams or either state level entrance exam. I think I have taken up only a couple of questions from state level entrance exam. All the other questions are directly from JEE mains and not from JEE advanced. So those students who are here for the first time, if you directly start visiting the topic, I would say it would harm your confidence level, because we have discussed many topics, many numericals which have a relatively low I would say demand of the subject, right? So these questions, they are at a I would say definitely at a concept level, but even at a higher conceptual level, wherein you need to understand the theoretical concepts very clearly, and only then you'll be able to apply those concepts in these questions. Unlike questions in the NEET, which also require conceptual understanding, but not at this depth. Well, of course, not all the questions, but generally, I would say generally, any random question selected at any question from JEE means selected at random would be at a more conceptual depth than that of the NEET exam. So please, I would repeatedly tell this to students: do not start attempting the previous year questions directly, because it may harm your confidence level. It will bring you down, because since you don't have enough practice on the basic level of questions, going directly into the higher level of questions won't fetch you any good. So please make sure you go through the previous numericals, try to solve them, and as usual I say, practice 100 questions from the chapter, then you can move on to previous year questions. That would be enough to get you a good, to get you a minimum amount of confidence to appear for exam. Okay, so having said so, let's now move on to the solution now. So what's given here is root x is equal to t plus 1. So if you differentiate the equation, what you get is 1 by 2 root x dx is equal to dt, or dx by dt is equal to 2 root x. We can say that dx by dt is equal to, what is root x from the question? Root x from the question is t plus 1. Now, what is dx by dt? Dx by dt is velocity, which is equal to 2 into t plus 1. So before we discuss the options, let me tell you one more thing. See, the same question can be, many a time students ask me this question: should we be squaring all the time? That's not required. You can do the question otherwise also. But let me solve the other way around. See, if this is question number 1, I mean equation number 1, and if you square this on both sides, right? So squaring on both sides, what does it becomes? It becomes root x the whole square is equal to t plus 1 the whole square. Now what is root x the whole square? X. What is t plus 1 the whole square? Yes, t square plus 2t plus 1. I do understand, but we are not going to expand this. We're just keeping it as t plus 1 the whole square. Now what we'll do is we'll differentiate on both sides. So now we'll take dx by dt and dx by dt here. So what do you get? dx by dt is now velocity. And what is d by dt of t plus 1 the whole square? It is 2 into t plus 1 into d by dt of t plus 1. So this gives us v is equal to 2 into t plus 1 again, right? So you can do it either ways, it doesn't matter, you get the same answer. Now, coming to the options. See, what we need to understand is let's say what we have derived is that v is equal to 2 into t plus 1 is what we have derived, right? Now, if you try to understand this in the conceptual way, we can say that okay, let's take this. V is equal to 2t plus 2, right? So basically, we can say that v is proportional to 2t right? Now t is a constant, sorry, 2 is a constant, therefore v is proportional to t. Now if v is proportional to t, what does this implies? It implies that as the value of v increases, or the other way around, as the value of t increases, v also increases. As the value of t decreases, v also decreases. So if a is proportional to b, it simply means that any increase in a is associated with the increase in b. And if a is inversely proportional to b, if a is inversely proportional to b, it means that any decrease in b results in an increasing a, and any increasing b results in a results in a decreasing a. Okay, so keep this in mind. I'll repeat it once again. If a is proportional to b, it means that if b increases, a also increases. If a is proportional to 1 by b, or if a is inversely proportional to b, it means that the value of, if the value of b decreases, a increases. So we can say that velocity increases with time, which means the correct option is option A. Particle is traveling along a straight line OX. The distance x in meter of the particle from O at a time is given by x equal to 37 plus 27t, where t is in second. The distance of the particle from origin O when it comes to rest is. I have to say these kind of questions never appear for JEE mains anymore. This is actually a a straight entrance level question. In fact, it is a straight entrance question. What I was trying to say is nowadays, right? These kind of questions never. We don't see these questions in JEE mains, or for that matter, even in NEET exam. Well, not to be disrespectful to the question, never. I was just trying to tell you the fact. Okay, so coming on to the question, what's given is x is equal to 37 plus 27t minus t cube. Distance of the particle when it comes to rest is being asked. See, when the object is at rest, or let us say like this, when the object comes to rest, what happens? When the object comes to rest, what happens is the velocity is equal to 0. Now what is velocity? Velocity is d by dt of x, which is equal to 0. So d by dt of x here is given as 37 plus 27t minus t cube is equal to 0. So this will become d by dt of 37 plus 27 into d by dt of t minus d by dt of t cube is equal to 0, which takes us to 0 plus 27 into d by dt of t is 1 minus d by dt of t cube is 3 into t to the power 3 minus 1 is equal to 0. So what we get is 27 minus 3t square is equal to 0, and therefore 27 is equal to 3t square. So 27 by 3 is equal to t square, and therefore t square is equal to 9, which means t is equal to 3. So the required value of t is equal to 3, but that is not what we are being asked to find out in the question. What we've been asked to find out is the distance of the particle when it comes to rest. So when it comes to rest, the time is 3 seconds, right? So 3 seconds after the observer started observing the motion, which means what is x? X is 37 plus 27t minus t cube. So we need to find out x at t is equal to 3, which is 37 plus 27 into 3 minus 3 cube, which is equal to 37 plus 27 to 3 is 7 3 is 21, 3 is 81, minus 3 cube is 27. So we can write this as so what is 37 minus 27? It is 10. So 10 plus 81. So 10 plus 81 is 91. Therefore, x at t is equal to 3 is 91, which gives us the answer to be option. Oh, wait. Yeah, okay. Option P. From a tower of height h, a particle is thrown vertically upwards with a speed u. The time taken by the particle to hit the ground is n times that taken by it to reach the highest point of its path. The relationship between h, u and n is. Okay, see, this is one question where I would say, the normal the methods of finding the answers will take much of time. Where what I mean is, where you can't sit and explore possible ways to get into solving the question. And having said that, I would say the very first time when I solved this question, when I was trying to solve this question on my own, see, it took me it really took me a long time to figure out the correct answer. I would say I have attempted this question at least 5 to 6 times in many ways, and it is then that we come into a conclusion to tell the students which method is the best to do. So what I'm trying to say is, when you have the solution in front of you, it becomes really simple. But when you try to find the solution on your own, it definitely becomes, it's a painful process, I would say. And most of the time what happens is, what I see among students is, when they try 3 to 4 times or maybe 5 to 6 times, they get fed up with the question, and then it really consumes the whole way of solving. It consumes the energy so much that you don't feel like solving further problems. That's one point. So what I have to suggest is, if you feel so, it's a very common thing. It is meant to happen to almost a whole majority of students. Some of them, I would say some of you may be able to solve this question in instant. Maybe you are fast at calculations, or maybe you have practiced these kind of questions otherwise so many times that the fastest approach to this question might be very clear to you. Otherwise, if you feel that you are not able to solve the question in a single shot, it doesn't mean that you are slow, or you may be it shouldn't demotivate you in any way. It is very common, and there is no harm to be in such a situation. Okay, all you should do is keep this question in your mind, or take this in a different way. If this question comes once again in an exam, or if a similar question comes in any other exam, will I be able to do that? Point number one. Number two, and most importantly, will I be able to do it more fastly than I was doing it the first time I got the question? So I think that's all what should be your priority. That's all what you should be trying to answer, in fact, is my opinion. Okay, so see, many people have different opinions on them. This is what I believe. So I would suggest, those people who are following the playlist very regularly, you'll be able to understand that the difficulty level is now slightly increasing. It was okay so far. I mean, all the individual problems that we have done, all the questions from NEET, what we have done. But this question onwards, I would say every question, it becomes, it takes us to a higher, it takes to a different, not a different level, yes, definitely a higher level of difficulty while solving the question, and it is very okay to be. Why? Because we are solving a JEE mains question paper. So definitely the questions would be, the questions would take some more time to solve the questions, to find the solution. So that's pretty okay to take such time. But as you practice more, the time required to solve one question will become less. Okay. So if you're taking more time, no issues. Just keep on practicing the question, do the question a couple of times, and then do similar questions. It will definitely improve in boosting your confidence. Okay. So now let us move on to this question. From a tower of height h. So first, let us draw a diagram. Say this is the tower. I'll mark this tower as A of height h, and let me mark this height as h. Okay, so a ball is projected. A particle is thrown vertically. Okay, so a particle is thrown vertically. It goes like this with a velocity u. it reaches the maximum height, let us say B. It comes back down to the ground, it falls into the ground, let us say that point. Let me mark an intermediate point here, C, and it comes down at D. Okay. Now, what is given in the question is the time taken by the particle to hit the ground. So let me write down that fully. Time taken by the particle, time taken to hit the ground, right? Time taken to hit the ground is equal to n times what? N times time taken to reach the highest point. Okay. Time taken to reach the highest point. Now what I'll do is I'll first consider the time taken to reach the highest point. See, time taken to reach the highest point, is basically time taken to reach the point B, right? Time taken to reach the highest point B, is basically time taken to reach the highest point is time taken to reach the point B, which is equal to time taken to travel distance AB, time taken to travel distance AB, right? Now, for the motion along AB, the equation of motion can be written as, first equation can be written as V is equal to U plus AT, right? Now, let us say T as time AB. Okay. Now, see, when a object is projected upwards at the maximum height, the object is momentarily at rest, a point that we have discussed time and time again while solving the questions. So it's momentarily at rest, which means at this point, velocity of the particle at B will be equal to 0. Which means this equation here, VB is equal to UA plus AATB, this term will be 0, right? So we have 0 is equal to U plus, what is A? Since the object is projected upwards, the acceleration due to gravity is taken minus G. So we can take minus G into TAB, right? So what is TAB now equal to? TAB will be equal to U by G. So this is one equation. TAB is equal to U by G. All right. Which means we can write the LHS of this equation as is equal to N into TAB. Now, what is the time taken to hit the ground? See, the object was here at A. It has gone this high. Then it retraces the path, and then it eventually comes to D, right? So the time taken to hit the path is basically time taken to cover the distance AD, or not distance, the displacement AD, right? I hope that difference is clear. The distance would be AB plus BC plus CD. We are talking about only the displacement, which means the time taken to hit the ground in terms of displacement is time taken to cover the displacement AD. Otherwise, if we are talking about distance, it should be T of AB plus T of BC plus T of CD. But here we are talking only specifically about the displacement. So time taken to cover AD as the displacement. So TAD is equal to N into TAB is one equation that we have. All right. Okay. Now, you may ask me what to do next, or for the exam point of view, what we'll be doing next, how to proceed to the next question, next part of the solution. It's very simple. What is given, what is common in all the options? We've been asked to find out H, right? The distance relationship between H has been asked. So definitely we need H. Now, what is H? For the motion along, for the motion along, or for the complete motion, right? For the complete travel, what is S? S is displacement. What is displacement? Displacement is final position minus the initial position. What is the final position? D. What is the initial position? A. So we can say that displacement is equal to dA, or displacement is equal to AD, right? But there is a difference here. Why? I'll tell you. See, the object is being projected upwards, right? And the final position is against the motion, initial direction of motion. I repeat, the initial velocity is upwards, the final position is against the initial direction of motion, which means displacement of the body will be negative. So S here will basically be equal to minus AD. Now what is AD from the question? See, AD from the question is equal to H, height of the tower. So S will be equal to minus H. Some people who are new to this may find a doubt here. I'll clear it now itself. This is the tower. If the object is projected with the velocity u upwards and if the final position is here, then what happens is the displacement is positive. But in this case, the object is projected with the velocity u upwards and the final position is downwards. So the displacement is taken as negative, right? See, these calculations, I mean, the way to take the symbols, I have repeatedly solved many problems, many similar questions. So please go through them. That will give you a more conceptual knowledge about why to take and when to take these symbols. Okay. Now, so if we write down the displacement time relation, what is it? S is equal to ut plus half at square, right? Now, what is S? We took it as minus H. What is U? U remains U alone. What is T here? T, we are talking about the complete travel. So this is T of AD plus half into, what is A? A is minus G. So this is minus G into, what is T here? T is T of AD. So this becomes T of AD the whole square. Now, oh, it's looking a bit slammed up. Okay, right. So I'll write down the equation once again here. So we have H is equal to, sorry, minus H is equal to UTAD plus minus G by 2 into TAD the whole square. So now if you go to the options, you have some related terms here. We have 2, G, H and U, right? So all the options have G, H, T and U. But what we don't have is, we don't have N, and what also we shouldn't be having in the equation is T, which means we need to eliminate TAD. Now what is TAD given to us? See, TAD we have given, it is given to us that it is N into TAB, which means again we write the equation as minus H is equal to U into, what is TAD? N into TAB minus, or say plus, minus G by 2 into, what is TAB? N into TAB the whole square. So this is minus H is equal to UN into TAB plus minus G by 2 into N square TAB the whole square. Now, does any of the options has T? No. Right, all options have G, H, N, 2 and U, but not TAB, which means now we need to include this TAB equation here. So what do we get? So what we get is minus H is equal to UN into, what is TAB? TAB is U by G plus minus G by 2 into N square into, what is TAB the whole square? That will become U square by G square. So this is further is equal to minus H is equal to U square into N by G plus minus, see now this minus G and G square, it will become G by G square will become G. So what we have in the numerator is N square U square by 2. Now here we have denominator G and we have 2G. So what I'll do is I'll multiply 2 in the numerator and multiply 2 in the denominator to make the denominator common. Then what we get is minus H is equal to 2U square N minus N square U square the whole upon 2G. If you cross multiply, what we get is minus 2GH is equal to, now we can take, both the terms have U square, so we can take U square, both take place of N, okay, so I can take N common here, which will give you 2 minus, did I make a mistake? Right, so we get 2 minus n. And now if you multiply negative on both sides, negative 1 into 2gh becomes positive 2gh is equal to u square n into 2 minus n into minus 1 will give you n minus 2. So the steps goes like this. You multiply this whole equation by minus 1 on both sides. So minus into minus is plus. This minus will go inside. Minus 1 into 2 will minus 2. Minus 1 into minus n will be positive n. So what we get is 2gh is equal to u square n into n minus 2. U square n into n minus 2 is the final relationship what we get, which makes the correct option as option 2gh is equal to u square n, option D. Okay, yes, I do understand the solution was lengthy. See, because I'm not trying to solve it in the exam environment, I'm trying to make sure that every student, whoever follows the explanation, should be able to make a detailed note on how to solve the question first. So when you practice this on your own, when maybe you do it a couple of times or maybe more than that, automatically your speeds get increased. Okay, so you should not try to solve the question in a quick way. You should practice it so many number of times that it automatically becomes, it becomes natural to you that you solve the question easily. Okay, so that was a very detailed solution I've written. When you solve for the question exam, you don't need to write these solutions. All you need to get the correct answer. So trust me, you'll be able to do it more when you practice the same question or when you practice similar questions more than once. So let's move on to the next question from JEE. A car is standing 200 meters behind a bus which is also at rest. The two start moving at the same instant but with different forward accelerations. The bus has acceleration 2 meters per second square and the car has an acceleration 4 meters per second square. The car will catch up the bus after time of. See, this is a very straightforward question based on relative velocity. We have done, let me try to recollect. So I think we've done around 10 to 15 questions on relative velocity, and I have covered almost every aspect of it. Okay, that saying that would be inappropriate. Not every aspect, but almost every aspect of solving the problems. At least based on previous questions. So those students who have already followed the playlist, you may be able to do this question right away. But since some other students also come to the playlist, let us make sure that you get a gist of it. So basically what's given here is there's a straight road here. We have a car, right? And a bus. The separation between them is 200 meters. Let us say the car has initial velocity UC, has initial velocity UB with acceleration AC and with acceleration AB. And both of them are moving towards a straight direction and both acceleration are in the forward direction. So let us take them to be positive. Now, what is the concept of relative motion? What we can do is, instead of considering these two bodies moving in a straight line in two different points, we can combine them together and then say that instead of car is chasing B, we can say this car is moving along with B with an acceleration of A of C with respect to B, and of course with speed U of C with respect to B, and then it is trying to cover the distance 200 meters. So let me repeat this once again. Instead of saying that car and bus are moving as two different entities, we'll take that both of them act as one in such a way that instead of car moving with AC acceleration and bus moving with AB acceleration, we consider both of them moving together with acceleration of C with respect to B, which means acceleration of C as seen from P. Now, what happens in this case is the equation of motion can be written as displacement time relation can be written as S is equal to UT plus half AT square. What is S? The relative separation, which is 200, is equal to U will be UCB into T plus half into A will be ACB into T square. We've asked to find out the time. Now, what is CB? Sorry, what is UCB? UCB is UC minus UB, right? Which is equal to 0. Since both of them are starting from rest. What is ACB? ACB is acceleration of car minus acceleration of bus, which is equal to acceleration of car is given to be 4, bus is given to be 2, so it is 4 minus 2 equal to 2. So the equation further reduces as 200 is equal to, this terms gets equal to 0. So half into acceleration of car with respect to bus is 2 into t square. 2 and 2 will cancel. So what we get is t square is equal to 200, in which case t is equal to root of 200, and therefore the answer is, okay, so 200 if you factorize, what we get is 10, right, and 10 and 2, so 200 will be written as root of 10 into 10 into 2, which is 10 root 2. Therefore the correct option is option C. This is a very straightforward question. At times the JEE mains also comprised of these kind of questions. See, these are the ones which will help you to score. Of course, they'll help you to score more, but these are the ones which will help you to spend more time on questions where you need additional time other than the average time for a typical question, like we did in the previous problem, right? Okay, so that's it with question number 5. Let's move on to the next JEE main question. All the graphs below are intended to represent the same motion. One of them does it incorrectly. Pick it up. Okay. So the moment we see option D, we should be able to say that this represents the velocity time graph of an object which is projected upwards from the ground. So all the graphs A, B, C and D we will discuss with respect to the same condition where an object is projected from the ground. Now this explanation may take a bit longer than usual, I would say. I think it would at least 10 to 15 minutes of explanation for all the 4 graphs. Why? Because I'll make sure that every concept is explained, okay, and every graph is explained right from the scratch. So starting with option A. So first the diagram, okay. So an object is projected. It comes to the topmost position, comes back and reaches the same position on the ground again. Now what we need to understand is this is the initial direction of motion. Is the initial direction of motion along the first half. And after the first half, it is the, so I would say after the topmost point, it is the final direction of motion, right? Final direction of motion. What I'm trying to say is the initial direction of motion is towards positive side and the final direction is towards the negative side. Okay. So we need to keep this point in mind. Now, what we'll do is we'll try to understand the velocity and the position relationship. Okay. So let us say this was the initial direction of the object, right? It reaches the top point, then comes down. So the object goes through these positions. See, the key to the very key thing to understand here is at same positions, when I say same positions, I mean towards the upward and the downward motion, speeds remain the same. Okay, speeds remain the same. Those who are listening to this concept for the first time, bear with me for a couple of minutes. Your concept will be clear. The idea will be clear. So let me mark these points: A, point B, point C, point D, point E, and point F. All right. And this point, let me call this as A dash, B dash, C dash, D dash, and E dash. Why have I chosen the same letters? Because they both of them are ideally the same point, but they just represent, E represent the upward motion and E dash represent the same point in the downward motion. Okay. Now, if we try to understand this further, let us say velocity at VA is VA, velocity at B is VB, velocity at C is VC, at D is VD, at V is VE. Okay, and velocity of F is definitely 0. But okay, now the velocity as E is V E dash, at V dash V D dash is V dash, at C dash position is velocity VC dash is VB dash is V A dash, right? What we need to understand is, see, every component what we take up, towards the upward direction is positive, and which comes downwards is negative. So we should write here that this is positive VA, this is positive VB, this is positive VC, this is positive VD, this is positive VE, this is negative VE dash, negative VD dash, negative VC dash, negative VB dash, and negative VA dash. All right. Now, what are we talking about? We're talking about velocity position graph. Okay. So what are the positions here? The positions are A, B, C, D, E, and A dash, B dash, C dash, A dash, and common position F. Okay. What are the corresponding velocities? VAA, VBB, VCC, VDD, VE. Okay. Now I'll take a numerical to explain you this further. So if I make use of a numerical, say it comes like this. Okay, why numerical? I'll tell you that also. I can actually directly correlate the graph with respect to this data itself, but I want to go to a numerical because only then you'll be able to understand graph C and graph T. We will come to that. So let us say the object was projected with velocity 10 meter per second. So I must write here plus 10. See, as the object is thrown upwards, the speed will definitely reduce down, right? Because you're pushing it against the gravity, so the speed will come down. Which means after some point it will be 9 meter per second, example, okay, plus 8 meter per second. So this is velocity, plus 7 meter per second, plus 6 meter per second, and say eventually 0. When it comes down, it will be at the same height, it will be minus 6 meter per second, it will be minus 7. Why is it increasing? Because downward direction, acceleration due to gravity is acting, it is acceleration, it will increase the speed. Okay, so it is minus 7, minus 8 meter per second, minus 9 meter per second, and minus 10 meter per second. All right. So the corresponding positions, I'll take the same positions again, which is at position A, at position B, C, D, E, and F. This is E dash, this is D dash, this is C dash, this is B dash, and A dash. Okay. Right. Now, if we try to plot the graph, what do we get? Let us see. Velocity, position. So this is plus V, this is minus V downwards. What are the positions? The positions are A, B, C, D, E, and F, right? And of course, A will overlap with A dash, B will overlap with B dash, C will overlap with C dash, D over D dash, E dash, and F dash. Now the velocity I've taken it from 10, 9, 8, 7, 6. Okay, so let's say this is 6, this is 7, 8, 9, 10, minus 6, minus 7, minus 8, minus 9, and minus 10. See, what is the first point, the first coordinate? The first coordinate is A, comma 10, right? What is the second coordinate? Second coordinate is B, comma positive 9. The third coordinate C, comma positive 8. All right. So just let us plot that A, comma 10. So okay, I think I should make a small correction in the naming here, because it should be A from here itself, right? A, B, C, D, E, and F. All right. Now, when the position was A, the velocity is 10 plus 10. So this is 1 point. This is 1 point, A comma 10, right? When second coordinate is B comma 9, so when the object is at B, the corresponding velocity is at 9. So this is B comma 9. What is the third coordinate? Third coordinate is C comma 8, right? C comma 8. Now I don't need to explain it further. What will be for D? It will be D comma 7. For E, it would be E comma 6. For F, it would be 0. Now, again, when it comes to E dash, it will be negative 6, D, negative 7, negative 8, negative 9, and when it is A dash, it will come to 10 again. So if you draw the curve, what you get is such a shape, right? Which coincides with what is given in option A, and therefore option A is correct. All right. So that is the explanation for the graph A. Now let us see the relationship with the graph C, which is actually the position time graph, right? Position time graph. So let's draw it here. The position time graph of this object. Now, how do we understand this? By using the same reference diagram, right? So, mind you, it's position time graph. Okay. So, the object is projected. Maximum height comes back. Let us say at t is equal to 0. At t is equal to 0, the object was here. Okay. At t is equal to 1, the object is here at A. At t is equal to 2, the object is here at B. At t is equal to 3, the object is here C. Then at D. At t is equal to 4, it is at T. At t is equal to 5, it is at C dash. At t is equal to 6, it is at B dash. At t is equal to 7, it is at A dash. All right. And at t is equal to 8 again, it comes to the origin, ground again. Okay. So now if we try to plot the graph, what do we get? Let's see. So what are the time coordinates? We have taken it as 1, 2, 3, 4, 5, 6, 7, and 8. And positions, we have taken it as A, B, C, and D, and then A overlaps with A dash, B dash, C dash, and D dash, and of course O. O and O dash will overlap. Now, what is the first coordinate here? 0, 0, which is this position, right? Second coordinate here, 1 and A. So we have 1 and A. Third coordinate is 2, B, right? This is 2, B. Now repeating the same should be your responsibility. The fourth coordinate would be exactly. The fourth coordinate should be fifth coordinate would be, sixth would be, seventh would be, and again eighth would be, which means we get a graph like this, right? So option C is also correct. The position time relationship is also correct here. Now, if you try to understand this in the mathematical part of this, see, what is the displacement time relation or the position time relation is given by S is equal to ut plus half at square, right? So S is basically U with ut plus half into A here is minus G into T square. So S is ut minus half gt square. Basically what does this represents? This represents that the position time relation should be what in nature? Should be a parabolic curve in nature. Now, is the position time given to be parabolic in nature? Yes. So that is also another way of saying that, having a look at the same graph. Okay. All right. Now moving on to the option B, which is distance time relationship. Okay, not position time. This time it's distance time. All right. So when we discuss about distance time relationship, where do I draw this? Okay, so let me try to explain distance time relationship now. Distance time relationship. Okay, this time what we'll do is we'll try to understand the graph mathematically. Okay, so the curve is, this is distance here, this time here. The curve is given roughly something like this, right? Now see, what is slope of the tangent is equal to? Slope of the tangent is equal to change in y-axis by change in x-axis, which here is change in distance by change in time, right? Change in distance by change in time. Now what is slope is equal to? So slope is equal to dy by dx, which is here is d by dt of distance, which is nothing but velocity, right? Which is nothing but velocity. Oh, sorry, it's displacement, right? So it is nothing but speed. So the slope here will give you the magnitude of speed. Let us try to understand the graph. See, if you draw a tangent here, it will go like this, right? If you draw a tangent here, come like this. If you draw a tangent here, go like this, like this. So let me call these points as point A, point B, and point C. Okay. So I can write from the graph that slope at A is greater than slope at B is greater than slope at C. Direct inference from the graph, right? Now, when slope of A is greater, what is slope? Slope is speed, which means speed at A is greater than speed at B is greater than speed at C. Which means the graph is trying to give an impression that as time increases, speed also increases, right? But let us now have a look at the speed time relationship here. See, here what you can see is as time increases, speed actually decreases first. 10, 9, 8, 7, 6. And then as time increases, the speed increases further. Okay. So if we write it down, we can say that during the upward motion, right? During the upward motion, speed actually decreases. But during the downward motion, what happens? So what happens during downward motion is that speed gradually increases. But this graph gives us an impression that speed always is increasing, and therefore this is a wrong representation of the graph. So the correct option here is to pick it incorrectly, which is option C. Now let us discuss option D also. So option D is velocity time relationship. Okay, so if we try to understand the velocity time relationship, let us have a look at that also. Velocity time relationship. Now we'll do both analysis here, mathematical as well as the graphical part. Okay, so the object is projected, right? It reaches the maximum height. It then comes back to the normal position, back to the ground. We know that the velocity is, say, plus 10, plus 9, plus 8, plus 7, plus 6, plus 5. And then when it comes down, it is 0, negative 5, sorry, negative 6, negative 7, negative 8, negative 9, and negative 10. All right. So let us assume this is at t is equal to 0, t is equal to 1 seconds, t is equal to 2 seconds, this is t is 3 seconds, this is t is 4 seconds, this is t is 5 seconds, this is t at 6 seconds, 7 seconds, 8 seconds, 9 seconds, 10 seconds, and 11 seconds, followed by, wait, did I go wrong? 1, 2, 3, 4, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay, 12 seconds. All right. 0, 1, 2, 3, 4, 5, 5, okay. 1, oops, sorry. 0, 1, 2, 3, 4, 4, this is 5, then this is 6, 5 is 7, 6 is 8, 9, okay, all right. Now, what we can see from the graph here is, this is velocity, this is velocity, this is positive velocity, negative velocity, and time, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, have a look at this. The velocity, okay, let me write down the velocity also. 1, 2, 3, 4, 5 velocities. We should be starting from 10, right? So 10, 9, 8, 7, 6, 5, 4. Okay, so there's 5, 6, 7, 8, 9, and 10. We have minus 5, minus 6, minus 7, minus 8, minus 9, and minus 10. So what is the first point? 0, 10. All right, 0, 10. Second point is 1, 9. So at 1 seconds, the velocity is 9. Then it is 2, 8. It's here. 3, 7. Like this, like this, like this. And eventually it's at 0, right? Eventually it is at 0. So this is the graph you obtain. Now what does this represent? This represents the first half of the motion. And what happens in the second half is that the velocity goes further like this and eventually comes to this point. So what is the second? This represents, below this is the velocity time graph during the second half of the motion, or that is the when the particle is coming downwards. Now let us have a look at the diagram. Look at the graph given. Is it the same graph given? Yes. So this is also the correct representation. Now, trying to understand this in a mathematical way. If you try to understand this graph in a mathematical way, and if you are being asked to find out whether it is right or wrong, how will you do that? See, if we understand that during the first half, this line represents a negative slope, right? What does negative slope implies? Negative slope implies that the dv by dt is negative. The change in y-axis by change in x-axis is negative. What is dv by dt? It is acceleration. So it is acceleration is equal to negative. Is it true? Yes, because when the object is projected up, acceleration is equal to minus g. So yes, that part is correct. Now, this simply gives a correlation that since a is minus g, what happens is the velocity will be given by the relation v is equal to u plus at, which is basically v is equal to u plus minus gt. Therefore, v is equal to u minus gt, right? And now if you try to understand with the mathematical part, this can be written as y is equal to c plus mx, right? So x is the t coordinate here, x is time here, y is velocity here, it is given, in which case what is c? C is the initial velocity, which is the intercept. So this much distance is the initial velocity. Yes, it is u. And what is the slope? The slope is minus g. The slope of the tangent is minus g. It resonates with the given graph, and therefore option D is also correct. So I think I have given every possible explanation, mathematical as well as physical, using a diagram for every graph possible. This should be, I think there's no point in, skipping the explanation. So I think I've given the comprehensive explanation. If there is any doubt which you feel should be addressed, please feel free to ask. I'll give a better explanation if possible. All right, so we have another question based on graph. which says the velocity time graphs of a car and a scooter are given. Car and a scooter are given. Find the difference between the distance traveled by the car and the scooter in 15 seconds and the time at which the car will catch up with the scooter. All right. So what we need to primarily understand here is the concept behind the graph here, which is velocity is equal to d by dt of x. Okay. So what is v into dt is equal to? V into dt is equal to dx. I'll write it down once again. V into dt is equal to dx. Now we integrate on both sides. If you integrate on both sides with limit 0 to t v dt and limit x1 to x2 dx, what is integral dx? Integral dx is x, so x varying from x1 to x2. Now what is x varying from x1 to x2? It is x2 minus x1. Okay. Now when we have x2 minus x1, what is this meaning? This is the difference in the position at time t minus position t and position at time t is equal to 0. Now what is that basically equal to? That is basically equal to the distance moved. That is equal to the distance moved where? Distance moved in time t. Okay. So that is about the RHS. Now what about the LHS? See, integral t 0 to t v dt. Say for example, if this is the graph, right? This is velocity on the y-axis, time on the x-axis, and if this is the graph, what we need to understand is this. If this is from 0 to t, then integral 0 to t means this much of area under the graph from 0 to t. Okay, from 0 to t. Now, so 0 to t v dt means area under the graph from 0 to t. So the conclusion here is that area under the graph from 0 to t will give you the distance moved in time t. I repeat, area under the graph from 0 to t will give you the distance moved in time t. Alright. Now, what I'll do is, so if you have understood the previous explanation, we can now, using the same idea, we can calculate the area under the graph for these two bodies, which is car and scooter individually now. Okay. How do we do that? See, area under the graph of car from t is equal to 0 to t is equal to 15 will give you the what? Will give the distance moved by the car, right? Will give the distance moved by the car in t is equal to 0 to t is equal to 15. Which means, what is area under the graph for this curve? See, this is the curve here, right? This is the curve for the graph. Curve for the car. And up to t is equal to 15, this much is the area under the curve, right? This highlighted region is the area under the curve. So we can say that area under the graph is basically area. So this is OAC. So say area OAC is equal to distance moved by the car, which I write it as distance moved by the car in t is equal to 15 seconds. Okay. Now, what is area OAC? See, area OAC is basically equal to area of triangle OAC from the figure directly, right? So OAC is basically a triangle, a right angle triangle. Now what is the area of right angle triangle? Is half into OC into AC, right? So this much distance is OC. From the graph it is 15, right? So this is half into 15 into how much is AC? So AC from the figure is this much of distance, which is equal to 45. So we can write here into 45, right? So what is this equal to? Distance moved by the car in 15. T is equal to 15. Now 45 into 15. It's 45 into 15, 5, 5, 25. 5 was 20 plus 2 is 22. 5 is 5, 4. So we get 6, 7, 5. Then we have 675 by 2, which gives us 2, 3, 2, 3, 6. 675 by 2, 2, 3, 6. Then is 7. Again is 3 to 6. 15. 7 is 14. 307.5. Okay. So what we get is distance moved by the car is 337.5 meters. So this is one part of the answer. Distance moved by the car is 337.5 meters. It would be better if you highlight it. So distance moved by the car is 337.5 meters. Okay. Now let us use the same idea to find the area under the to find the distance moved by the scooter. And how do we do that? The only difference here is area under the graph of car from t is equal to 0 to 15 will be replaced by area under the graph of scooter will be equal to distance moved by the scooter in t is equal to 0 to t is equal to 15. Now, what is area under the graph here? See, area under the graph is, first we need to draw the graph. So this is the graph. So area under the graph from 0 to 15 means area under the graph up to this, right? So I'll use a different color to highlight. So it is this area what we are talking about, right? Now, what is area under the graph t is equal to 0 to 15? It is, if you name it, say O, A, B, S for scooter, right? So we have area of OABC is equal to distance moved by the scooter. Now, if you observe the figure, what is OABS? Geometrically, this is a rectangle. So this becomes area of rectangle OABC. Now, what is area of rectangle OABC? It is length into breadth. What is length? OS is the length. What is the breadth? BS is the breadth. So what is this equal to? Distance moved by the scooter. Now, measure of OS is 15. Measure of BS is 30. So this can be written as 15 into 30. And therefore, distance moved by the scooter is 15.3, which is 450 meter. So we have got two values, distance moved by the car and distance moved by the scooter. Now what is the first part of the question? It is to find the difference between the distances moved in t is equal to 15. Therefore we can say that distance moved by the scooter minus distance moved by the car is equal to 450 meter minus 337.5 meter, which gives us 112.5 meters. Okay, let us come to the options. So there are two options which says 112.5. Now we need to find out the rest, which is time at which the car will catch up with the scooter. Okay, how do we do that? I'll give you a detailed explanation on that too. See, let us assume that the car will the car will catch up the scooter after t seconds. So it will catch after t seconds, after 15 seconds. Okay, so it will move till 15 seconds, and after t is equal to 15 seconds, it will move another t seconds, and then it will overtake. Now, what is the condition for overtaking? We know that when overtaking will take place, distance moved by the car, right? Distance moved by the car will be equal to the distance moved by the distance moved by the scooter. Okay, some people may have a doubt there also. I'll just give you one graphical understanding about that. See, there were two bodies which were starting from the same position, bodies 1 and 2. One was moving with some velocity, 2 was also moving with some velocity. After a certain time, 1 and 2 were in the same point again, which this is where we say that one has catched up with 2, or one has started overtaking 2. Okay, so when this has happened, we need to understand that 1 is also moving, 2 is also moving. At the second position, this is the distance moved by 1, and this much is the distance moved by 2. So when the distance moved by 1 is less than that of 2, the body 1 will stay behind body 2. But when the distance moved by 1 is equal to the distance moved by 2, what can we say? When the distance moved by body 1 is equal to the distance moved by body 2, we can say that both of them have discovered the same distance, or that one has started to overtake 2, or that one has caught up with the body 2. Very similarly, when the car and the scooter has traveled the same distance, we can say that car will catch up with the scooter. Alright. So what I'm assuming here is the overtaking takes place t seconds after t is equal to 15. So let us assume that this much of time is t. Okay, so the overall duration at which the overtaking takes place is 15 plus t. Now, what is distance moved by the car? Distance moved by the car is area under the curve, right? Area under the curve from where? From 0 to t. Now see, 0 to 2 can be calculated as two halves. One, area under the graph from 0 to 15, and the next area under the graph from 15 to t. Okay, so this will be the distance moved by the scooter while overtaking. Now, what is area under the graph from 0 to 15? See, this is the area under the graph from 0 to 15. How much is that? We already calculated that. What was the value? 112. No, it was 337.5. So that distance is 337.5 meter plus area moved under the graph from 15 to t. See, 15 to t means it is a rectangle. We are talking about this area, right? We're talking about this area. Now, what is area of rectangle? It is length into breadth. What is length here? Length is time, because it is t. What is breadth? Breadth is this much distance, and how much is that? It is 45. So this becomes 45 into t is equal to distance moved by the scooter. Sorry, distance moved by the car. I'm sorry. This is distance moved by the car. Distance moved by the car. Now, again, the explanation repeats the same here. So the overtaking takes place after some time t. Say this is that time t. Okay. So the complete duration of travel is 15 seconds plus t seconds, which means I can rewrite the same notion here. So it is distance moved by the scooter. Right, distance moved by the scooter is what we are trying to calculate, is equal to area under the curve, right? Area under which curve? Area under the VT graph. Now, area under the VT graph from which time? From t is equal to 0 to t is equal to t. So distance moved by the scooter will be equal to area under the graph from 0 to 15 plus area under the graph from 15 to t, right? Okay, since this is a direct rectangle, we can actually calculate the area directly. How? I'll tell you. See, this is the required area what we are talking about, right? That area is basically a rectangle. Say rectangle O A B S, right? That is area of rectangle OABS, which is equal to length into breadth. What is the length? The length is 15 plus t. What is the breadth? The breadth is 30. So what is area of distance moved by the scooter? It is 450 plus 30t. Okay. Now we're trying to do, what were we trying to do? We were trying to find the time taken to overtake. And what was the condition? The condition was that when they overtake, the distance moved by the car and the distance moved by the scooter will be equal, which means we can equate these two values here, distance moved by the car and that of the scooter. So if we equate it, what do we get? We get 337.5 plus 45t is equal to 450 plus 30t. So 445 minus 30t is 15t. So 15t is equal to 450 minus 337 is 112.5. So we have t is equal to 112.5 divided by 15. So t is equal to cancelled by 5. 5 2s are 10, 20, 5 4s are 20, 5, wait, 5 2s are 10, 112, 5 2s are 10 again, 25, 225, 225 by 3, so 22.5 by 3. So t is equal to 7 3s are 21, 15, 7.5. So t, the value of t is 7.5. Now, what did we say? We said that, what did we assume? We assumed that the overtaking is done after t is equal to 15 by moving through a gap when the body is moving through t seconds. So we have 15 plus t, which is 7.5. So it is 22.5, which means the overtaking will take place after 22.5 seconds, which gives us the answer to be 22.5 seconds, option D. In a car race on a straight road, car A takes a time t less than car B at the finish and passes finishing point with a speed v more than that of car B. That's car B, sorry for that. Both the cars start from rest and travel with constant acceleration a1 and a2 respectively. Then v is equal to. Alright. So let us first write down what's given in the question. So we've been given two cars, car A and car B. I'll assume it's a1 and a2, right? So let us take the velocities as v1 and v2. Time taken, any variable assigned? No. Time taken as t1 and t2. Acceleration as a1 and a2. According to the question, it is given that velocity of car A is v more than that of car B, right? And it is also given that time taken by car 1 is t less than time taken by car 2. As soon as I write this, I convert the equation in terms of v. So what is v is equal to? v1 minus v2. I convert the second equation in terms of t. So what is t is equal to? T is equal to t2 minus t1. Alright. So I'll mark this as equation number 1, this as equation number 2. I'll divide equation 2 with 1. So what do we get? V by t is equal to v1 minus v2 the whole upon t2 minus t1. Okay. After writing this, we will try deriving the values of v1 and v2 in terms of a1 and a2 what we require. So what is v square minus u square is equal to? V square minus u square is 2as. So what is that for the car A? car A, it is V1 square minus U square. Since it is starting from rest, it is 0. So it is V1 square minus 0 is equal to 2 into A1 into S. Okay, both of them travel the same distance. So it is S and S, not S1 and S2 here. Okay, now how would it look like for the car B? For the car B, this would look like V2 square is equal to 2 into A2 into S, right? So what is V1 from here? V1 from here is root of 2A1 into S. And what is V2 from here? V2 is equal to root of 2A2 into S. Okay. So we have found out the value of V1 and V2 here. Now, we need T2 and T1. Okay. So how do you do that? Let us see. See, what is S is equal to? S is equal to ut plus half at square. So for the first car A, this will be S is equal to U is 0, 0 into T1 plus half into A1 T1 square, right? So what is T1 out of that? T1 will be equal to root of 2S by A1, okay? What is this for the car B? For the car B, this is S is equal to 0 into T2 plus half into AT square, which is half into A2 T2 square. So what is T2 out of this? T2 is root of 2S by A2. Okay. So now we have value of V1, value of V2, value of T1, right? And then also value of T2. So if we have all these, what can we do? We can substitute in this if this derived equation, V by T is equal to V1, V2 minus V1 minus V2 by T2 minus T1. Let us see if we do that, what do we get? So what we get is V by T is equal to, what is V1? Root of 2A into 2A1 into S, right? Minus V2 is root of 2A2 into S, the whole upon. What is T2? T2 is from here, is root of 2S upon A2 minus what is root of, what is T1? T1 is 2S upon root of A1. Okay. So we can later write that V by T is equal to, now I'll try to make it as simple as possible, the calculation. So I'll write it as A1 into root of 2S minus root of A2 into root of 2S. So if you ask me why am I separating 2 and S, because none of the options given here have 2 and S in the within them. So that's why I'm trying to eliminate S and 2 from the equations that we are approaching now. So this becomes root of, you can write this as root 2S into 1 by root A2 minus 1 by root A1 into root of 2S. Okay. So this becomes V by T is equal to, now what I'll do is I'll take root 2S common from numerator as well as from the denominator. So what we are left is root A1 minus root A2, the whole upon root 2S into 1 by root A2 minus 1 by root A1. So V by T, we get it as V by T. Now root 2S and root 2S cancel. So V by T, we get it as root of A1 minus root of A2, the whole upon 1 by root A2 minus 1 by root A1. Okay. which implies further implies v by 2 is equal to root a1 minus root a2 whole upon root a1 minus root a2 by root of a2 into root of a1. Why? This is basically like this. So it's 1 by a minus 1 by b is equal to b minus a by ab. That's what I've done here. Okay. And doing so, v by t will be equal to c. Both of these terms will get cancelled off, and what we get is 1 by root of a2 into a1. So v by t becomes v by t is equal to root of a1 into t, and therefore v is equal to root a1 into root a2 into t, which gives us the correct option as a particle starts from the origin time t is equal to 0 and moves along the positive x-axis. The graph of the velocity with respect to time, which means what we are given is the vt graph. What is the position of the particle at the time t is equal to 5 seconds? Okay, so we have already discussed a similar question, but I would like to describe the concept once again. So what is velocity is equal to? Velocity is equal to rate of change of t by dt of position, that is x. So what is v dt is equal to? So we have v dt is equal to dx. If you integrate on both sides from time 0 to time t and dx from x1 to xt, what we get on the LHS is, that is integral 0 to t v dt is nothing but area under the graph. So we have area under the graph from time t is equal to 0 to t is equal to integral of dx is x varying from x1 to x2 is x2 minus x1. Now what is x2 minus x1? It is the distance moved by the object, right? Distance moved by the object, which means if you have a velocity time graph, and if there is a specified time interval mentioned, say from 0 to t, the area under this graph will give you the distance moved by the object. Okay, so very simple question. So what we asked to find out is particle at time t is equal to 5 seconds. See, at t is equal to 5 seconds, where is the graph? The graph, okay, there's a minor mistake in drawing the graph here. See, it's actually, it goes through this, not below 3, it is through 3. Okay, so it is not below 2, it is actually through 2. Okay, so this is the graph given, right? And we have been asked to find out the value till time t is equal to 5 seconds. So maybe up to this. So this is the boundary we are talking about. So what we need is area under this graph. So this is the area what we are talking about, right? This much area. Now see, if you ask me to find this as easily as possible, I would say, see, one typical square here measures 1 into 1, right? Because it's 7, 8, 9, the unit is 1 here, the unit is also 1 in the y-axis, so it's 1 into 1, which is 1, which means there are 1, 2, 3, 4, 5, 6, 7 and 8 full squares, sorry, 8 full squares. So we have 8 into 1, which is 8, and then how many half do we have? We have 2 halves here, so we have half into 2, which is 1, so we have 8 plus 1, 9, so the correct answer is 9. That's as simple as that. But let us try to, for those people who are here to understand, to make the subject very clear, let me explain the concept again very clearly. So basically what we can say is, oh, this graph was okay. So this is the graph which is given to us. This is the graph given to us. All right. And t is equal to 5 is what we've been asked to find out. Okay. So what we'll do is we'll split this figure into 3 different figures. 1, 2, and 3. Let me shade them for you. So this is figure 1. All right. This is figure 1. And this is figure 2, which is actually area 2. And the third one is area 3. Okay. It's getting a bit uneasy to identify. So I'll rather use the shaded portion. So let us say so we've been asked to find out this much area under the curve, right? So we'll use 3 different areas to calculate. This will be area 1, highlighted in red. Let us mark that as O, A, and B. So area 1 is triangle O, A, B, right? Now what is the second area? The second area, see, it depends upon how you approach the question, but as of now, let me consider this much to be the second area. Say A, B, C, D. Okay. So A2 is equal to rectangle B, A, C, D. Right? Rectangle B, A, C, D. And we have another area here, which is a very small area, which is A3. We know that is from the figure length into breadth 1 into 1. So it is 1 into 1. All right. Okay. Now, what is area of triangle OAB? So the distance traveled is equal to distance traveled is equal to sum of all this, right? Which is A1 plus A2 plus A3. So what is area 1? Triangle OAB. So what is area of triangle OAB? Half into base. What is base? Base is 2. Half into what is height? Height is also 2. Half into 2 into 2 plus. What is area of rectangle BACD? Length into breadth, right? What is length? Length is BD. What is breadth? Breadth is AB. What is the measure of BD? It is 1, 2, and 3. What is the measure of AB? It is 1, 2. So we have 3 into 2 plus A3, which is 1. Okay, so this becomes 2 into 2, 2 into 2 can cancel. So we get 2 plus 3 plus 2 is, so 3 into 2 is 6 plus 1. So 6 plus 2 is 8 plus 1, 9. Therefore, the correct option is option 9. A particle starts from origin, from rest, and moves with a uniform acceleration along the positive x-axis. Identify all the figure that correctly represents the motion qualitatively. Okay, so we'll go through each and every figure and try to understand the representation. So this is the first figure given to us. Now, what is the y-axis here? The y-axis here represents acceleration. And what is the x-axis? The x-axis represents the time. If we try to understand this in the graphical sense, we can conclude from the graph that slope of the graph, right? Slope of the graph here. See, what is slope of the graph? If you have a y-axis, t-axis here, if there is a curve here, the angle theta, the tan of this angle theta is what we call as slope of the graph. So this is the graph given to us here. Does it make any angle with the positive x-axis or the x-axis? No. So the angle here is 0. Therefore, slope of graph is 0. Now, what is slope of the graph numerically? Numerically, slope of the graph is change in y-axis by change in x-axis. What is y-axis here? acceleration, right? So we can write that this is change in acceleration by what is x-axis? Change in time is equal to 0. Now when d by dt of acceleration is equal to 0, it simply means that, see, d by dt of a constant is equal to 0. So if d by dt of constant is equal to 0 and if d by dt of acceleration is equal to 0, what is the meaning? What is the inference from that? It means that acceleration is equal to k, or acceleration is a constant, or in other words, this goes hand in hand with our question because it says uniform acceleration. So yes, this option is correct. It is uniform in nature. Now let us look at the second graph. Again, what is y-axis here? So the y-axis here represents velocity. What is the x-axis? X-axis represents the time. So x-axis represents the time. So what is slope of the graph is equal to? Slope of the tangent is equal to? Slope of the tangent will be equal to the change in y-axis by change in x-axis, which here is change in velocity by change in time. Now what is change in velocity by time is equal to? It is equal to acceleration. So if you take the slope of the graph here, it will be equal to acceleration. Now see, here the graph is going such that there is always one slope of theta, right? So the slope here is tan theta, and since theta doesn't vary, since theta is equal to constant, tan theta is also equal to constant. Now if theta is constant, if tan theta is constant, what is slope is equal to? Slope is equal to tan theta is equal to constant. Therefore slope is constant. What is slope? Slope of the tangent is acceleration. Therefore we can write that acceleration is equal to, acceleration is a constant value, which again is concurring with the sentence, with the question given to us. Now coming to the third graph. Okay, the third graph here. Third graph, the y-axis represents the x, which is the position, represents the position, and what does the x-axis represents? X-axis represents the time. Now if we so we have x and t, right? X and t. Okay, now how do you interpret this graphically? Okay, so what is the distance time relationship? In general, distance time relationship is s is equal to ut plus half a t square. Since the body is starting from rest here, this term will be 0. So s is equal to half into a t square. Now we can say that s is proportional to t square, right? S is proportional to t square, and if s is proportional to t square, we know that the corresponding graph would be, a second degree equation would be represented by a parabolic curve. Which may give us a conclusion that this is correct. But there's a problem. Why? What is it? See, if we understand the slope of the graph here, see, it is continuously reducing, right? It is continuously reducing. So some students may have a doubt here. Let me clear that part also. See, this represents an increasing slope, okay? And this curve represents an decreasing slope. So what here happens is the slope is decreasing after a specific amount of, or after a specific time interval. Okay, so if the slope is decreasing, what is the meaning? Slope is decreasing means slope, which is equal to dx by dt, is increasing. What is dx by dt? Dx by dt is velocity. So we can say that velocity is increasing in this graph. So when velocity is decreasing in this graph. If velocity is decreasing, what is the acceleration? Acceleration should also be decreasing. But in the given question, it says that the acceleration in the object is constant acceleration. But what do we infer from the graph here? That the acceleration is decreasing, which means this option is wrong. Okay. Now, now let us move on to the fourth graph. Right. Now, looking at the fourth graph here. Again, what is x-axis? X-axis represents the position. What is y-axis? Y-axis represents the time. Now, what is the nature of the graph here? This is an graph with increasing slope. This is a graph with increasing slope. In which case, if slope is increasing, what is slope is equal to? Slope is equal to change in y-axis by change in time. That is also increasing. What is change in y-axis? It is change in position. What is change in x-axis? It is change in time. So what is d by dt of position? It is velocity. So if slope is increasing, velocity is also increasing. When velocity is increasing, what does it mean? See, when velocity of a body will increase only when there is acceleration acting on it, which means that this option is also correct. Now, if we try to understand in a mathematical sense, let us see what is displacement time relationship. S is equal to ut plus half at square. The object is at rest, so this is 0. So this will be S is equal to half at square, and therefore we can say that S is proportional to t square, and thus the graph should be a second degree equation is represented by a parabolic curve. Since we are given a parabolic curve here, it should be correct, and therefore parabolic curve is given, so this option is correct. Now you may argue, isn't that the same case with option 3 also? That is also a parabolic curve, but there's a problem. I'll tell you what. See, the graph here, it starts from a specific value above the origin. Okay, now what is this point? It represents the y-intercept, right? It represents the y-intercept. It means that at this point, distance that the object has already covered. So this much distance is from where the motion has started to take place. Now, if you try to read the question, it says that it starts from origin. Now, the fourth graph, it very clearly says that the curve is parabolic, but where does it start from? It starts from the origin. So the intercept here is 0, and that is why, using the second concept of parabolic curve, this graph is correct, and the third graph is incorrect. Okay. So that's it with another question for graph. Let us move on to the next JEE mains question. A particle is moving with speed v is equal to b root x along positive x-axis. Calculate the speed of the particle at time t is equal to 2. Okay, so this is a simple question, but is a bit tricky to solve. So let us start by writing what is given to us. So the question says that v is equal to b root x. This is purely an application of differentiation and integration. What is v? V is d by dt of x. So this is equal to b root x. So I can write dx upon root x is equal to b into dt, right? Now what I'll do is I'll multiply 2 on numerator and denominator and write like this: 2 into dx by 2 root x is equal to b dt. Why did I do this? It is to make sure that we get this derivative. What is derivative of root x? D by dx of root x is equal to 1 by 2 root x, right? So that's why we have multiplied this 2 here. Now if we integrate on both sides, what do we get? We get 2 into, what is integral of 1 by 2 root x? It is root x. So we have 2 root x is equal to b into what is integral of dt? It is t. So we can write that 2 root x is equal to bt. Now if we square this on both sides, what do we get? 4 into root x square, which is x, is equal to b square t square. So it otherwise means that x is equal to b square by 4 into t square. Now what is d by dt of x equal to now? So d by dt of x will now be equal to b square by 4 into d by dt of t square. Now what is d by dt of x? It is velocity v. So v will be equal to b square by 4 into d square by dt of d by dt of t square is 2t. So we get velocity is equal to b square by 4 into t, and we've been asked to find out the velocity at t is equal to tau. So this becomes v is equal to 2b square tau by 4. Oh, okay, we can simplify this. So this is v is equal to b square tau by 2. B square tau by 2. Correct option, option C. The instantaneous velocity of a particle is in a straight line is v is equal to alpha t plus beta t square. The distance traveled by the particle between 1 second and 2 seconds is. So very simple question, straightforward application of integration. So what's given is v is equal to, for ease of calculation, I'll let it as at plus bt square. Okay. What is v? V is dx by dt. So dx by dt is equal to at plus bt square. So dx is equal to at plus bt square the whole times dt. So if you integrate this, what do you get? X is equal to integral 1 to 2. Why 1 to 2? Because the question says 1 seconds and 2 seconds, right? 1 to 2. So what is integral a t? It is a into t square by 2 plus b into, what is integral t square? What is integral of t raised to n? Integral of t raised to n is equal to t to the power n plus 1 the whole upon n plus 1. So this is b into t to the power 2 plus 1. Okay, let me just write down directly. T cube by 3, right? So the whole varying from 1 to 2. So x we can write it as a by 2 into t square varying from 1 to 2 plus b by 3 into t cube varying from 1 to 2. So what is x is equal to? A by 2 into 2 square minus 1 square plus b by 3 into upper limit 2, 2 cube minus lower limit 1, 1 cube. So x is equal to a by 2 into 4 minus 1 plus b by 3 into 8 minus 1. So x is 3a by 2 plus 7b by 3, which is 3 alpha by 2 plus 7 beta by 3. 3 alpha by 2 plus 7 by 3 beta, option D. A ball is thrown up with a certain velocity so that it reaches the height h. Find the ratio of the two different times of the ball reaching h by 3 in both directions. So a ball is thrown up from the ground. A ball is thrown up from the ground, say with velocity u. Okay. It reaches the maximum height, then it comes back to the ground. Say this height is, total height is h. This height is h, and say this much height is h by 3. For reference, I'll take these points as A, B, and C. Okay. So for the motion along AC, we can say that v square minus u square is equal to 2 into a into s. But what we need to keep in mind is, at this point, the object is momentarily at rest. The object is momentarily at rest, which means the velocity here will be equal to 0. So we have for AB, initial velocity u is equal to u and final velocity v is equal to 0. So if we substitute these values, what do you get? 0 is equal to minus u square is equal to 2 into, since the object is projected upwards, acceleration due to gravity taken downwards is minus g. So it is 2 into minus g into the whole height is h. So what is u is equal to? U is equal to root of 2gh. Now what we can write is, we can change this u and instead we can write u as root of 2gh. Okay. So I hope that much portion is clear. Now let us consider the motion of the body only from the ground till the height h by 3. So it is projected from the ground. It is projected from the ground with the velocity u. What is u is equal to? U is equal to root of 2gh, and it reaches velocity. So this is, we are talking about motion from A to B with corresponding velocity being b, and the displacement now being h by 3. At this point of time, what would be the equation, displacement time relationship? Wait, what can we find out v now? So v here will be equal to, vb will be equal to u plus at. What is vb? So vb will be equal to u of root of 2gh minus gt, and then we can find out v square minus u square is equal to 2 into a into s. So we'll have v, we have u again. Will that be difficult? Okay, let us try both methods. So we have v is equal to root of 2gh minus gt. Oh, this doesn't make sense. Why? Because it will make the equation very complex. Anyway, let me just write down that part also. So this is v square minus u square is root of 2gh the whole square is equal to 2 into a into, what is a? A is minus g into s is h by 3 here, right? Now, if we expand this equation, what do we get? What we get is a minus b the whole square, which is a square plus b square minus 2 into a into b minus root of 2gh the whole square is 2gh is equal to minus 2gh upon 3, right? So what is root of 2gh the whole square? It is 2gh plus g square t square minus 2g t into root of 2gh minus 2gh is equal to minus 2gh by 3. Now 2gh and minus 2gh is 0. So what is left is, so basically what we left here is g square t square minus 2gt into root of 2gh is equal to minus 2g into h by 3. Okay. Now how do we solve this question? So okay, g is there in every term, right? G is there in every term. So we'll divide this entire equation by g. So what do we get? What we get is g square t square minus, wait. So if we divide this entire equation by g, so this is by g, by g, by g. what do we get? So this becomes gt square minus 2t into root of 2gh is equal to minus 2h by 3. See, now what I'll do here is I'll slightly rearrange the equation like this: plus minus 2 root 2gh into t plus 2h by 3 is equal to 0. And why did I do so? Because I wanted in the form 8t square plus bt plus c is equal to 0. Why? Why do we need it? Because it's a quadratic equation and it will help us in sorting out the values easily. So we have a is equal to t, sorry, a is equal to g. Similarly, what is b is equal to? B is t here, sorry, b is minus 2 into root of 2gh, and what is c? C here will be 2h by 3. Now that we have the quadratic equation in terms of t, what can we write? We can write that solution t is equal to minus b plus or minus root of b square minus 4ac the whole upon 2a. So what is t is equal to? T is equal to minus b. Minus b is minus into minus, so it is plus 2 root 2gh plus or minus root of what is b square is 2 root 2h is the whole square, so that is 4 into 2 into gh minus 4ac is 4 into g into 2h by 3 the whole upon 2a. A is g, so this is 2g. So t is equal to 2 into root of 2gh plus or minus root of 4 into 2 is 8gh minus 4 into 2 is 8gh by 3. So this is 8gh by 3 the whole upon 2g, right? Now t will be equal to 2 into root of 2gh plus or minus root of how do we do the calculation? How do we make it simple? Okay, so 8 into 3 is 24. 24 minus 8 is 16, right? So this is root of 8 into 3 is 24. 24 minus 8 is 16. So this is root of 16 gh whole upon, now by 3 I'll write it as root 3, by root 3, okay, the whole upon 2g. So t will be equal to 2 into root of 2gh plus or minus root of, what is root of 16gh? We can, okay, I'll write it as root of 2gh into root of 8, okay, the whole upon, sorry, not the whole upon, the whole upon root 3, and now the whole numerator divided by 2g. So t will be equal to, if I take 2 root 2gh here, I can multiply root 3 over here, so this becomes root 3 plus or minus root of 2gh into root 8 the whole upon root 3 into 2g, right? So t here can be written as t is equal to, now what I'll do is I'll take root of 2gh common, wait, that's not the only common term here, so okay, let's continue writing. So 2 into so this becomes 2 into root of 2gh into root 3 plus or minus root of 2gh into, see, root 8 can be written as 2 root 2, right? 2 root 2 the whole upon root 3 into 2g. So t can now be written as, if I take 2 root 2 common from the numerator, we have 2 into root of 2gh within brackets, all what is left is root 3 plus or minus root 3 plus or minus root 2 the whole upon root 3 into 2g. So what is t now is equal to? T is equal to 2 root 2 into 2gh by root 3 into 2g into root 3 plus or minus root 3 plus or minus root 2. Now, what we need to understand here is we'll get two values for t now, right? So we have t1 and t2. See, since the object is moving upwards, it will reach the height h by 3 in a smaller value, right, in a smaller time. But okay, I think it would be better if I draw a diagram and explain. So if the object is moving upward, this much distance h by 3 will be achieved in, say, time t1. Okay, while if it is coming back, the same distance, the same displacement h by 3 is obtained in time t2. We can clearly say that t2 is greater than t1. So while you take the roots here, while you express the answer here, you should make sure that you give t1 is equal to 2 into root of 2gh the whole upon root 3 into 2g, okay, into root 3 minus root 2 because it's a less value. And what would be t2 then? T2 would be equal to 2 root 2gh the whole upon 2 into root 3g into plus root 2. Okay. Now if you divide on both sides, what do you get? T1 by T2 is equal to, these two terms will cancel off. All we are left is root 3 minus root 2 the whole upon root 3 plus root 2, which gives us the correct answer as root 3 minus root 2 by root 2 plus root 2, option C. Two buses P and Q start from a point at the same time and move in a straight line, and their positions are represented by XP and XQ. At what time will they have the same velocity? So what's given to us is position of P is given as AT plus BT square, and position of Q is given as FT minus T square. We know that d by dt of xp will give us velocity of p, which is equal to a into d by dt of t plus p into d by dt of t square. Similarly, d by dt of xq will give us f into d by dt of t minus d by dt of t square. So what is Vp is equal to? Vp is equal to a into d by dt of dt is 1, d by dt of t square is 2t. So Vp is a plus 2bt. Similarly, what is Vq? Vq is f minus 2t. Now when both the velocities are same, say Vp is equal to Vq, we have a plus 2bt is equal to f minus 2t. So a minus f is equal to minus 2t minus 2bt. So a minus f is equal to t into minus 2 minus 2b, and therefore t is equal to a minus f the whole upon minus 2 minus tb, or this is equal to f minus a the whole upon 2 plus 2b. So it is f minus a by 2 plus 2b is their option. F minus a alpha f minus a by 2 into 1 plus beta. Yes. So okay, so if you need to take 2 common here. So this will become equal to f minus a the whole upon, if you take 2 common, what do you get? 1 plus b. Yes, f minus a by 2 into 1 plus b, option D. If the velocity of a body related to displacement is given by v is equal to, okay, related to displacement is given by v is equal to root of 5000 plus 24x, then the acceleration of the body is, okay, so what we are given is, we are given v is equal to root of 5000 plus 24x, right? So then the acceleration of the body is, okay, so what is v square is equal to? V square will be equal to 5000 plus 24x, right? And if you differentiate this equation, what do we get? What we get is, okay, now that depends upon what, with respect to what do we differentiate. Okay, so I'll write it down. So we have v square is equal to 24x is equal to, see, if we need to obtain acceleration, then we need to differentiate velocity with respect to time and not with respect to displacement. So all the measurement as given here is with respect to displacement. So what I'll do is I'll differentiate d by dt with respect to v square, and we'll also take the RHS with respect to time. Now what we get is d by dt of v square. See, most of the students make a mistake here. They write it as 2v. No, it is not. It is 2v when it is d by dt of t square is 2t. D by dt of v square is, sorry, d by dv of v square is 2v. But d by dt of v square is 2v dv by dt. Okay, so this is 2v into dv by dt is equal to, d by dt of 5000 is 0, so that becomes 0 plus 24 into dx by dt. So dv by dt is acceleration, a is equal to 24 into dx by dt is velocity v. So we have 2a is equal to 24, and therefore a is equal to 12. Therefore the correct okay, so the acceleration of the body is 12 meter per second square. Okay, the distance covered by a particle is given to be x square is equal to at square plus, this is a minor error here, it is x square plus at square plus 2bt plus c. If acceleration of the particle depends on x as x raised to x to the power n, where n is an integer, the value of, it's not x, it is value of n is. Okay, now let us start writing the solution. So we have x square is equal to at square plus 2bt plus c. So when I differentiate this equation, what do you get? 2x into dx by dt is equal to 2at plus 2b, right? So we can write it otherwise, that x into v, because dx by dt is v, x into v is equal to at plus p, right? Now, so this was equation number 1. Let me say this is equation number 2. So if I differentiate this 2 further, what do we get? Now we need to use the product rule, which is d by dt of u into v is uv dash plus v u dash. Two functions here. So first into derivative of second plus second into derivative of first is equal to derivative of at plus b is a. So this becomes x into dv by dt is acceleration. If I use a again here, it will be, okay, so we'll let capital A plus v into dx by dt is v. This is equal to a. So we get the equation right. X into capital A plus v square is equal to a. Okay. So what is capital A from here? Capital A from here is a minus v square by x. Okay. Now what is v? V from 1 is at plus b the whole upon x. So what will this equation reduce to? So a will now be equal to a minus, what is v? V from this equation is at plus b by x. So I'll write it here, at plus b by x. So this will be the whole square, right? The whole square, the whole upon x. So a will be equal to a minus at plus b the whole square, the whole upon x square, the whole upon x, which I'll write it as a into x square minus at plus b the whole square, the whole upon x square into x, right? So this will be equal to, if we open the bracket, what do we get? This will be equal to a into x square minus a square t square minus b square minus 2 into a into t into b the whole upon x cube, right? So a is equal to, or capital A is equal to a into x square. What is x square given as? X square is given from the equation as at square plus 2pt plus c minus a square t square minus b square minus 2at into b the whole upon x cube. So see, actually you can stop solving the question here itself, because all the numerator terms consist only of a, t and b, which means acceleration a is proportional to 1 by x cube, or acceleration a is proportional to x to the power minus 3. So the required value of n is equal to minus 3. You can stop solving the question now itself, but let me just continue the rest also. So this becomes a square t square plus 2abt plus ac minus a square t square minus 2atp whole upon x cube. So a square and t square cancel, 2abt is cancelled. So all what is left is a is equal to a into c upon x cube. Oh, sorry, there is one more term here. This is minus b square. So we have ac minus b square by x cube. Therefore, a is proportional to x raised to minus 3.